All right, let's do some convex mirror problems. The biggest trick here is when we go to find our images, is doing the math. I recommend you not try to do it with your calculator. I recommend you find a least common denominator. So if I'm looking for, say, if I'm looking for the focal point, all right, least common denominator would be SOSI. What do I need to multiply this by to get that? Well, I need to make S multiply through by SI over SI. And here I need to multiply by S over SO. So, and then invert. So that F is SO, SI, divided by SI plus SO. Now with a convex mirror, my focus is always negative. You're always going to have an upright, virtual, reduced image. An upright pencil is placed in front of a convex mirror with a focal length of 8 centimeters. So F is negative 8 centimeters. And I know it's negative because it's convex. An upright image, HI, 2.5 centimeters tall, is formed 4.44 centimeters behind the mirror. So this is, let me get rid of that. The image distance is 4.44 centimeters, and it's behind the mirror. Well, there's no light really behind the mirror, is there? So it's a virtual image. Find the position of the object, etc. So 1 over F is 1 over SO plus 1 over SI. I'm going to solve this for SO. 1 over SO is 1 over F minus 1 over SI. And get a common denominator of FSI. So this is SI minus F is 1 over SO. So SO is F SI divided by SI minus F. Now this was not, these weren't going to be pretty numbers, so I didn't want to try to find least common denominator. I mean, there were 2 and 4, pretty easy. All right, so my object distance is my focal length, which is negative 8, times SI, which is negative 4.44, divided by SI, which is negative 4.44, minus F, which is negative 8. All right, now let's be careful with our calculators. Negative times negative 8 times negative 8 times negative 4.44 is 35.52. Now let's do the subtraction. Negative 4.44. Now let me mess that up. Negative 4.44 minus the negative 8 is the same thing as plus 8. So this is positive 3.56. All right, so 35.52 divided by 3.56 is 9.9775. So let's call it 9.98 meters, centimeters. Find the magnification. Magnification is minus SI over SO. So it's minus SI is negative 4.44 divided by SO, which is 9.98. Okay, this is going to be positive. 4.44 divided by 9.98 gives me a magnification of positive 0.445. And I want the height of the pencil. All right, magnification is also equal to HI over HO. So let's see, let me see the height of my object. Clear fractions. So HO times magnification, those cancel, that's HI. So my object is HI divided by the magnification. So my image height is 2.5 centimeters, and my magnification is 0.445. So 2.5 divided by 4.45 gives me a height of my object of 5.6, let's just call it 2 centimeters. All right, is it real or virtual? let's see. My image distance is negative. That means it is, let me find it, it's virtual. My magnification is positive, so that means it's upright. Is it reduced or enlarged? Well, this is less than 1, which makes it reduced. All right, the image of a crayon appears to be 23 centimeters behind the surface of a convex mirror and is 1.7 centimeters tall. All right. The mirror's focal length is 46. Where's the object distance? Basically is what we're asking for. So the image, SI, excuse me, is 23 centimeters, and that's behind. So that's negative. And the convex mirror has a focal length is negative 46 centimeters, and it's negative because it's convex. And the height of the image is 1.7 centimeters tall. So the first thing we need to do is find everything about this. So the first thing we need to find is the object distance. 1 over F is 1 over SO plus 1 over SI. So 1 over F is, common denominator here is SOSI. So, didn't want to do that, did I? Man, I just love making mistakes. Always nice to see a teacher make a mistake, isn't it? I'm looking for the object distance. So 1 over SO is 1 over F minus 1 over SI. So now I get a common denominator of F, SI. None of these are going to be pretty. So this is SI minus F. Actually, you know, this one would have been all right. You want to do it that way? Let's do it the easy way. I know, I'm getting frustrating on this problem. I'm going to plug the numbers in. Sorry, those of you erasing. So this is 1 over F, which is negative 46, minus 1 over SI, which is negative 23. So let's get a common denominator of 46. So this is going to be 46. Negative, so it's 46. 46. Common denominator 46, so that's negative 1. Plus, let's see, I need to multiply 2 over 2. So this is 2 minus 1 over 46. So my object distance is, let's see, this is 1 over 46, is just 46. Sorry. It's been a long day. All right, magnification is minus SI over SO. My image distance is negative 23. My object distance is 46. These are positive. 23 divided by 46 is 0.5. Now let's find the height of my object. I know the magnification is HI over HO. So the height of the object is going to be the height of the image divided by the magnification. Just a little cross multiplying there. Okay. Use whatever math actually works. So HI is 1.7. My magnification is 0.5. So 1.7 divided by 0.5 is 3.4 centimeters. Now let's see if we can figure out if these are all right. Let's see. My image distance is negative, and that tells me it's virtual. My magnification is positive, so it tells me it's upright. The reduced or enlarged. Magnification is less than 1. Sorry about that. Having pen breakdowns. Magnification is less than 1, which tells me it's reduced. Good job. A convex mirror with focal length of 0.25. So the focus is negative 0.25. Forms a point. Oh my gosh, I don't know what's wrong with my pen. I'm sorry, folks. Forms a 0.8 meter tall image. So the height of my image is 0.08 meters of an automobile with a distance of 0.24 meters behind the mirror. So the image distance is 0.24 meters, and it's behind the mirror, so that's going to be negative. Find the location, indication, image height, image characteristics. Okay, so basically we need to find everything. So 1 over f is 1 over SO plus 1 over SI. First thing you always have to find is the object distance, or the image distance, or the focus. That's where you have to start. So 1 over SO is what we're looking for. It's 1 over f minus 1 over SI. Now we're going to do this one a little bit differently because I'm going to show you yet another way to do these. So plug in your numbers. Minus 0.25 minus 1 over SI, which is minus 0.24. Now, go on and do these calculations. 1 divided by 0.25 gives you 4, and you're going to be negative. So this is negative 4 minus a negative gives you a plus. Now, 1 over 0.24 is 4.1667. Now this is 1 over SO. Go ahead and do this. You're going to see this is going to be 0.16667, but this is 1 over SO. Now what you can do is what's called just invert, or just flip it. 1 divided by 1.1667 gives me an object distance of 6. If you can't do this with your calculator and you get confused, that's okay. Just go back to doing it the way we were doing it. But I wind up with an object distance of 6 centimeters. Now here's a hint, folks. If for some reason you get a negative 6, you know you've made a mistake. Your object distance is always going to be positive. All right, so the magnification is minus SI over SO. So it's minus a negative 0.24 divided by 6. So that's positive. Now, 0.24 divided by 6 gives me a magnification of positive 0.04. Now, I have the image height. I need the object height. So I know the magnification is the image height divided by the object height. I'll step through this one, HO. So HO times M equals, those cancel, HI. So my object height, I'm going to divide both sides through by M. So this is my image height, which is 0.08, divided by my magnification, which is 0.04. And I get, this is 2 meters. Now, let's go on and figure out what the variety of things are. My image is negative, so it is virtual. Magnification is positive, so it's upright. And the magnification is less than 1. The absolute value of it, 0.04, is less than 1, so it's reduced. A convex mirror. By the way, these are much harder than what I'm going to give you on the test, believe me. A convex mirror with a focal length of 0.33 centimeters. So my focus is negative 33 centimeters. Forms an image of a soda bottle at a distance 19 centimeters behind the mirror. This is SI. So SI is 19 centimeters, and it's behind the mirror, so it's negative. If the height of the image, HI, is 7 centimeters, find basically everything. All right, 1 over F is 1 over SO plus 1 over SI. Let's do it this way. Let's go and plug our numbers in. 1 over negative 33. That's 1 over SO plus 1 over negative 19. Again, there are several ways you can do these. So now I'm going to add negative 19 to both sides. So 1 over SO is 1 over negative 33 plus 1 over 19. What do you say on this one? We get a common denominator. I'm not seeing anything real neat. So 33 times 19 is a common denominator of 627 centimeters squared. It's kind of ugly. So this will be, let's see, I have to multiply by 19 over 19 here, and 33 over 33 here. So it'll be negative 19 plus 33. So let's see. This is negative 19 plus 33 is 14. That's positive, divided by 627. And that's 1 over SO. So SO is 627 divided by 14. And that number is 44.78. Let's just call it 8 centimeters. All right, the magnification is minus SI over SO. So it's minus SI is 19, SO is 44.8. So it's going to be positive 19 divided by 44.8 gives me 0.42. 4. Do we want the object height? I know the magnification is plus, it's equal to the image height divided by the object height. I'm looking for the object height. So HO times M is HI. So the object height is HI divided by M, which is my image height, which is 7 centimeters divided by 0.424. All right. So I get 16.5. And you may get something slightly off. If you don't leave the numbers in your calculator, then you'll wind up being just a little bit off. I'm not worried about that. All right. Is it real? Let's see. My image distance is negative, so it's virtual. Is it inverted or upright? My magnification is positive, so it's upright. Is it reduced or enlarged? My magnification is less than 1, so it is reduced.